We're now going to talk about how predefined non-concurrent collectors are implemented. And we'll see that there's a bunch that come out of the box. There's also ways that you can define your own. And the way that they come out of the box actually provides you some mechanisms that are used to define things yourself. So as you recall, Collectors is a Java utility class that has a bunch of factory methods that create collectors for various common collection types. So things like lists and sets and maps and so on. Recall a utility class in Java is a final class. That means you can't subclass from it. It has only static methods, no non-static methods. It has no non-static state. It can have static state. Usually it has no state. And it can also have it must have a private constructor. That just means you can't make an instance of a utility class. Basically, you can think of a utility class in Java as a namespace in C++ that has a bunch of methods defined in it that are basically functions. There's a class that's part of the implementation of Java streams called CollectorImpl that defines a very simple implementation class that's used to make different types of collectors. And this is what it looks like. You can see that CollectorImpl is going to essentially implement the collector interface, and it's part of the collectors class. It's nested inside of it. What's interesting, however, is that CollectorImpl is private. So you can't access it unless you work for Oracle and you're a Java implementer. You're implementing the Java class library. So it's only used internally, but let's see how it's used internally. So here's how Collectors.toList, which is a public method, uses CollectorImpl, which is a private class, to return a non-concurrent collector that accumulates input elements into a new list implemented as an array list. So here's what it looks like. Here's toList. Here's CollectorImpl. We make a new CollectorImpl. The supplier is an array list new. So that's the supplier constructor reference that's passed in. The accumulator is list add, which is what's used to accumulate things into the array list. And then we have a combiner that takes the left and the right, two lists, and it adds the right to the left to preserve in counter order and returns the left. Note that this is only used if parallel streams is involved. And then we have this characteristic set, which says ch_id, which stands for identity finish. So since it's a list, we can do identity finish. There's no need to do anything fancy with a finisher. So that's what toList looks like. Let's go ahead and take a look at toSet. You can see that this is used to make a non-concurrent collector that accumulates input elements into a new set, implemented as a hash set. Here's toSet, new CollectorImpl. Hash set is the supplier type constructor reference. Set add is the accumulator method reference. And then here's what the combiner does. I had to kind of split it up because otherwise it would run off the page. So it takes a left and a right set, and if the left size is less than the right size, we're going to add the left to the right and return the right. Otherwise, we're going to add the right to the left. The whole idea here is to optimize things by always adding the smaller set to the larger set. There's less work involved in doing that because we don't have to add as many elements and put them into the set. Once again, the combiner is only used for parallel streams. Then finally, you have the characteristic set, which is going to have this ch_unordered_id, which is basically unordered and identity finish, because a set doesn't require the encounter order to be maintained. So those are two of the methods that are public that use CollectorImpl. Then there's another method, actually two more methods, called Collector.of. And this defines a public factor method that implements a collector. So you can see this particular version is passed 4 parameters where the last parameter is optional. That's what the ... means here under characteristics. So we don't have to provide that. And you can see that what it does is it calls CollectorImpl, passing in these 4 values. And then there's also a 5-parameter version, which will take something in addition. Notice this one doesn't take the finisher. This one does take the finisher. And once again, the characteristics parameter is optional, so you don't have to provide it. So this is the way you typically use these things in practice. And we're going to see essentially how that is done here shortly. Note that both of these of factory methods use the private CollectorImpl class we looked at before. So that is reused in a number of different ways by each of these methods that are public methods. So that's the end of how the predefined non-concurrent collectors are implemented. There's a bunch more than those, but I didn't want to spend time going through each one, but this gives you a flavor of how they work under the hood. It also is nice because it demonstrates the concept of making a framework where you can abstract away common behavior and then parameterize things with method references or lambda expressions in order to minimize the amount of code duplication you would otherwise have to have.